Calculus, Part 5. Application of calculus in graphs. How to apply calculus in graphs and the functions. Increasing and decreasing functions. We are going to learn how to determine whether a function is increasing at a particular point or decreasing at a particular point. Look at the graph of function f, and we look at an interval between a and b, and there is a tangent. What is the gradient of that tangent? Is it positive or negative? We can see that it is sloping to the right. We learned in analytical geometry the gradient of that straight line will be positive. Okay? Now, if the gradient is positive, what is the relationship between gradient and derivative? F dash of x, the derivative is positive or greater than 0. Now, if f dash x, the derivative is positive or greater than 0, we say the function is increasing in that interval. Over the interval, what is the interval? From a to b. So, depending on the derivative, calculate the derivative and substitute the x value there. If x equal to 3, you substitute 3 and find f dash 3. So we can see if you get a positive number as your answer, then we say the function is increasing in that interval. Look at the next graph. Again, there is a tangent. The interval is clear there. What will be the gradient of this tangent? It is sloping to the left, and we know that it is negative gradient. The gradient of the tangent will be negative. And what will be the derivative? Derivative also will be less than 0 or negative, because the gradient is negative. Gradient means derivative. So f dash x will be negative when you substitute and a value for x, you will get a negative number there. So we say f dash x is less than 0. When f dash x is less than 0 in the interval, now we say this function is decreasing over the interval ab. So that is how we identify increasing and decreasing. If f dash x is greater than 0 or positive, we say increasing. If f dash x is less than 0 or negative, we say the function is decreasing. Moving on to next information, maximum or minimum. Turning points. Look at the turning points there. In the first graph, you can see the point A, x value of the turning point is A. To the left of A, the function is increasing there. We can see f dash x is greater than 0. All the x values left of A, less than A. So from left up to x equal to A, it is increasing. What about the right side? After A, x greater than A, f dash x is less than 0, negative gradient. That is decreasing. So first it is increasing and then it is decreasing. Now look at the turning point. What we say? We say it is a maximum turning point. From the graph itself we know that, but if the graph, even if the graph is not there, we must decide from the derivatives. So if you have a point, instead of A, if it is 2, then you take another point onto the left, another number on the right, and then you decide whether it is negative answer or positive answer. Then you decide increasing or decreasing. We can say the turning point is a maximum or minimum. Look at the second graph. Before we go, we look at the tangent at the point. A tangent at the turning point. What will be the gradient of that? It is parallel to the x-axis. So the gradient is equal to 0. So we say f dash of a, x is a, f dash a equal to 0. Look at the second graph. Okay, x less than b, smaller than b, and the tangent is there, negative gradient, so it is decreasing up to the point b. Then on the right side, x is greater than b, and it is increasing, decreasing, and then increasing. So what will be the turning point? It is called a minimum turning point. And the tangent again at x equal to b, or what is the gradient? F dash b will be equal to 0. Consider the graph of fx equal to x square plus 2x minus 3, a beautiful parabola. What is our question? Determine the coordinates of the turning point. So we apply calculus again here. We know how to calculate the turning point of a parabola. We learned it in grade 10, grade 11, and in functions. So we learned x coordinate, or the axis of symmetry, minus b over 2a. Or even if you know the x-intercepts, the middle point will be the x value, x coordinate of the turning point. But here we have to learn this calculus, because in future we are going to have cubic graphs. So that's why we introduce this method here. We apply differentiation, we apply derivative. So at the turning point, we have already seen that f dash x equal to 0. So we find the derivative here. Derivative of x square plus 2x minus 3, which is 2x plus 2, equal to 0. Therefore, 2x equal to minus 2, x equal to minus 1. What is the meaning? The x coordinate of the turning point is minus 1. Once we know the x coordinate, we calculate the corresponding y coordinate, substituting into the function, original function. So we substitute minus 1 there, and we get on the calculator, you do it on the calculator, we get minus 4. So the turning point, therefore the turning point is minus 1, minus 4. Can see that minus 1, minus 4, the turning point. Now we go on. Question B, determine the interval over which f is increasing and decreasing. We can easily find it from the diagram, very clear. To the left of minus 1, we can say, and right of minus 1. F is increasing for x greater than minus 1, increasing x greater than minus 1. Look at that. And decreasing for x less than minus 1. Look at that. Very simple. So the interval, you can answer the question like that. Number C, determine the gradient of the tangent to f at x equal to minus 4. Not at the turning point. It is at x equal to minus 4. What is the gradient of a tangent? So gradient of the tangent means we go for the derivative. Not anywhere on the graph, but we want a particular point where x is equal to minus 4. So we calculate the derivative, that is f dash x. F dash x is 2x plus 2. Then we calculate f dash of minus 4 because x is minus 4. We want the gradient at x equal to minus 4. We substitute and we get minus 6. So the gradient of the tangent at x equal to minus 4 is minus 6. Continue. Question D. Determine the coordinates of the point on F for which the gradient is equal to 12. Indirect question. So we substitute f dash x 12, 2x plus 2, 12. We simplify, we get x equal to 5. And then we substitute 5. We get the y coordinate 32. So the coordinate is 532. Graph of cubic function. Look at the question. The general equation is f of x. Okay, that is a general the cubic function. Ax cubed plus bx square plus cx plus d. Now, the shape of the graph can be decided by looking at the value of a, the number in front of x cubed. If a is positive, we say the shape is like this. If a is negative, look at the shape. Just basic idea. If a is a negative number, the shape is like that. Now, turning points on cubic function. We have already seen the increasing, decreasing. Again, we have a turning point. What is that? That one is local maximum turning point. Come to the next one. Decreasing, then increasing. What is that? It will be a local minimum turning point. Coming to the next graph. Decreasing, then increasing. What's the turning point? It's a minimum turning point. Then we have the last one. What will be that turning point called? It will be a local maximum turning point. These are all informations which will help you in this part of calculus. Now, point of inflection. What is that? Point of inflection is an important point depending on the concavity. Look at that. The part of the graph, that part is concave down, looking at the cup, you see, upside down. And this part is concave up. And there is a point in between the two turning points. Look at that turning point, where the concavity will change from concave down to concave up. And that point is called point of inflection. Very important information. And at that point, f double dash of a will be equal to 0. Second derivative. You go for the second derivative. We'll do a lot of questions on that point of inflection. Look at the tangent. It will be having gradient 0. Now that is the end of part 5. Hope you understood what is the important points about the graph and application of calculus in that. Enjoy the video. Watch again and again. Thank you.